This is experiment number 2, the following evening. I'm working on trying to find the resonant frequency of this water. But it's looking like I don't think we really need to find the resonant frequency of the water. We actually just have to find the resonant frequency of the high voltage circuit that is connected to the water, so that you can optimize its high voltage potential and increase the stored current on the water capacitor to the point where it can create the separation of the hydrogen and oxygen from the water. Anyway, I'm going to show you the setup again. As you can see, I've got 2 separate power supply. I'm isolating the dual timer circuit, which will be my low voltage circuit, and I have this power supply, which has a limit of around 3 amps, that is driving the it is now a power FET. Yesterday it was a Darlington transistor. I upgraded it to a power FET to drive this ignition coil. I have it with a cap so that there is resonance. The output, as you can see, I'm just clipped on the end of the plug so that I can get continuity from that high voltage output. It goes to a rectifier diode, which is about 15 kilovolts. I need to build a rectifier bridge that should handle about 40K. That's my goal, is to get about 40 kilovolts out of this setup. And I have a hand wound choke coil that is 2 coils in there. They're just opposite north-south. And it goes from there to 2 plates, which is right there, and immersed in water. Okay, now last night I showed you the thing arcing. Today I am going to show you what it's doing in resonance. I'm going to go ahead and get the scope signal in. As you can see, it is currently running at the voltage is pretty low. I'm going to bring it up to around 13 volts at 0.35 amps, and you can see the effect it has. Okay, now you can, if I go ahead and look at this thing, you can see the lower portion is the high voltage primary side. Even though it's on the primary side, you can even see the primary side ramping up with a large discharge when we have that separation between the 4 pulses. Okay, now I'm going to show you what it actually does at this voltage, which is at 13.6. I'm going to go ahead and turn it off just for a second, and I'm going to separate this thing, grab, let's see here, Here it is. Okay, we'll put this other spark plug so that you can see that it is running high voltage, and I have the spark right there. Okay, I'll turn on this unit. And on my scope. Okay, and bring up amperage back up. Okay, let's see what happens. So you can see it starts arcing, and there is the pulses. Same effect. If I lower this down, capture it again, you can see the ramp up there. But what's interesting is the ramp up is based on the high frequency spikes that are being created by the 4 pulses, and then the large one is from that longer duration that's here. It's actually really interesting. Anyway, there is the spark that's there. It's pretty interesting. Okay, there is no production of hydrogen at this point, but I think we are going the right direction. Let's want to show you something. Let me go ahead and separate these two a little bit, and I will take this little bulb, a big bulb, and put it right over this thing. So you can see it starts lighting up. So we know we're on got a high some high voltage potential there. Okay, so that's where we are. Any comments? Let me know. I think what I want to do next is see if I can get these ramp ups to be a lot more solid. I'm going to create a bigger gap between those 4 spikes so that I have more charge that can be dissipated and increase over time. Anyway, this is PLI2. See you next time. Bye-bye.